Okay, now let's talk about variation of resistance with temperature. Okay, in previous lesson, I did say that the resistivity role is dependent on temperature. You increase the temperature, increase the resistivity. In turns, it also affect the resistance. Okay, resistivity, that's why I said the resistivity depend on temperature. If temperature increase, resistivity will increase. When resistivity increase, yeah, just like that, yeah. When I increase the temperature, resistivity will increase. When resistivity increase, because of the formula rho L over A, so the resistance also is affected. Okay. So when temperature increase, resistivity and resistance will increase. Now, resistance is this is a resistance at temperature T, and R naught, resistance R naught is the resistance at temperature T naught. Okay. Same goes to the resistivity. Now, by applying V equal to IR formula, we can change the resistance to voltage over current. So you get another formula for this. If the voltage of the circuit is constant, we can cancel the voltage and we get the current. So sometimes the questions tell you about the changes of resistance when change of temperature. But sometimes the question doesn't tell you about the changes of resistance. It tells you about the changes of current. So can also, yeah, we can because we can also use talk about the changes of current. Because why? Because when resistance changes, the current sure changes in the circuit. Because we know that if the resistance increase, temperature will decrease. So changes in the resistance will cause changes in the current as well. Okay, when resistance increase, the current will decrease. So we can say that if temperature increase, the resistance will increase, and then in the end, the temperature will decrease. Yeah, resistance increase, temperature will decrease. So there are three formulas for you to use. Yeah, about the resistance, about the resistivity, and about the current. Okay, current changes with the changes in temperature. Okay, now what is all this alpha? What is the T naught? This is very important. Yeah, what is alpha? What is T naught? First of all, what is alpha? Alpha is known as temperature coefficient of resistance. Yeah, temperature coefficient of resistance. So maybe I should write off all this. Yeah, make it so that it's not messy at all. Now, about the unit of alpha. How to get a unit of alpha? We know that from here we know that resistance is ohm. Okay, R is ohm. R not also ohm. Okay, so their unit already cancel, isn't it? So inside here no more unit, That means the temperature. This is the changes in temperature. Yeah, this is actually delta T. This is actually delta T. Delta T can be either degrees Celsius or Kelvin. Not necessarily must be Kelvin alone. Yeah, when talk about changes of temperature, change of temperature, the change of 1 degree Celsius is the same as the change of 1 Kelvin, isn't it? Increase 1 degree Celsius is the same as increase 1 Kelvin. So that's why the change of temperature, you can either use degree Celsius or Kelvin. So you no need to change to Kelvin. Yeah, if given degree Celsius, just use degree Celsius. If given Kelvin, just use Kelvin. So you no need to change to the SI unit Kelvin. Yeah, you can also use degree Celsius. And that's why alpha, the unit is per degree Celsius, or per Kelvin. Why? Alpha will be per degree Celsius or per Kelvin. Because they can cancel off. Later they can cancel off per degree Celsius with degree Celsius or per Kelvin with Kelvin. So they can cancel off. So alpha unit is per degree Celsius or per Kelvin. Okay, understand? Okay, now let's rub this off. Yeah, let's rub them off. Now, I want to talk about this alpha. Alpha has different value depend on the reference temperature. And what is reference temperature? Okay, let's not talk about alpha first. Let's talk about T naught first. Yeah, let's talk about T naught. T naught, what do you think it is? Some of you may think that T naught is the initial temperature. Some of you may think that, oh, T naught is the initial temperature and T must be the final temperature, isn't it? And R naught is the initial resistance, R is the final resistance, isn't it? This is wrong. Here, this T naught is not about initial. Yeah, this here is not about initial or final. Wrong concept. T naught here is not the initial temperature. T naught here, a bit different from what we learned before. T naught here is called reference temperature. It's not the initial temperature. Yeah. So here is a misconception that you need to take note. Yeah, it is not the initial temperature. Okay, T naught is not the initial temperature. It is known as reference temperature. What is meant by reference temperature? Reference temperature has a specific value. It has a specific value. It can be either room temperature. Normally reference temperature is 20 degrees Celsius. This is most common. This one is the most common one. 20 degrees Celsius is the most common reference temperature. As soon as we look at the questions, the question mentioned about 20 degrees Celsius, that must be reference temperature without any more thinking. Yeah, that must be the reference temperature already. As long as you look at, if the question, one of the temperature is 20 degrees Celsius, you straight away put the 20 degrees Celsius as the T naught, as the reference temperature. No need any more thinking. Yeah. So reference temperature can only be these specific values. It's either the room temperature. Room temperature can be a range of value from 20 to 30 degrees Celsius. Sometimes the question didn't give you 20 degrees Celsius. Sometimes it give you 30 degrees Celsius. That 30 degrees Celsius also you can put as the T naught or the reference temperature. Okay. Sometimes he give you 30 instead of 20. And then instead of 20 or 30, sometimes the question give 23 degrees Celsius or 25 degrees Celsius or 27 degrees Celsius. All these can be accepted as the reference temperature, T naught. Okay? Or sometimes the T naught can be even 0 degrees Celsius. So the range of value that you can choose as T naught must be either 0 or 20 to 30. 20 to 30. Okay? So, but the most common reference temperature is 20 degrees Celsius. Why is this so important? Why they have specific value? Why the reference temperature have specific value? It is because alpha has this temperature coefficient of resistance has different value, has different coefficient at different reference temperature. And the alpha for our syllabus, for our matriculation syllabus, the alpha for matriculation syllabus, it is chosen at reference temperature of 20 degrees Celsius. Our alpha is alpha at 20 degrees Celsius. Because you have different alpha at different reference temperature. Yeah, you have alpha at 0 degrees Celsius. You have alpha at some other temperature. Yeah, some other temperature of reference temperature. So, and now for our syllabus, we use alpha at 20 degrees Celsius. We use this one. Okay? So, that's why you must maintain this 20 degrees Celsius as our T naught, as our T naught. You cannot change this T naught to other temperature. You cannot change T naught to 50 degrees Celsius. You cannot change to 60 degrees Celsius. You must maintain the T naught at 20 degrees Celsius. Okay? Because our alpha will have different value at different reference temperature. Okay? Right. That's all about this reference temperature. This reference temperature, if you see it has these values 20 to 30 or either 0, you can choose as the reference temperature T naught. Let me take one example to further clarify. Yeah, a caution here. Let's say I have an example here. Yeah, I have an example here. Let's say the initial temperature is 20 degrees Celsius. You heat up the metal to become 50 degrees Celsius. And so the 20 degrees Celsius is the initial temperature. The 50 degrees Celsius is the final temperature. And then the resistance corresponds to the temperature, like T naught, 20 degrees Celsius. At 20 degrees Celsius, the resistance is 4 ohm. So this one is the initial resistance. And this is the final temperature, 50 degrees Celsius. At this final temperature, it has 6 ohm resistance. Okay, so which one should be the reference temperature? Reference temperature, is it the 20 or 50? Of course, is 20 because we see 20 degrees Celsius is the room temperature, is the reference temperature. Yeah, it is definitely the reference temperature, 20. So when we use this formula, T minus T naught, we use 50 minus 20. Okay, no brainer. 20 must be the reference temperature. Now, what if the question the other way around? He says that 50 degrees Celsius is the initial temperature. Cool down. You cool down the conductor to 20 degrees Celsius. From initial is hot, you cool down. Before that is 20 become 50, you heat up. Now you cool down from 50 to 20. Now final is 20, initial is 50. So do you use a final minus initial? Final minus initial, which is the 20 minus 50? This is wrong. If you use 20 minus 50, wrong. Because this T naught is not about initial temperature. You cannot say, oh, my initial temperature now is 50. So I minus 50 lah. Yeah, I minus 50 because initial temperature is 50. So I minus 50. Wrong. You cannot do like that. It is still 20 degrees Celsius is the reference temperature. As I said, reference temperature, you must choose this value only. As long as you see this value, 20 to 30 or 0, no matter it is initial temperature or final temperature, that definitely automatically it is reference temperature. No brainer. Yeah? Straight away, this 20 degrees Celsius, no matter it is initial value or final, no matter 20 degrees Celsius is initial temperature or final temperature, automatically it must be the T naught, the reference temperature. So it is always for both condition, yeah, going to the right or going to the left, for both cases, it is always 50 minus 20. This 20 minus 50 is wrong. Yeah, 20 minus 50 is wrong. For either condition, 20 degrees Celsius must always be the reference temperature, and the 4 ohm, which is the resistance at this 20 degrees Celsius, must be the R naught. Okay? Because if you do the other way around, 20 minus 50, you will get a different answer. Trust me, you will get a different answer compared to you use 50 minus 20. Especially if the question asks you to find, like it give you all these 4 values. It give you this T naught, T, and then R naught, R, and then the question asks you to find what? Asks you to find the alpha. He give you all these four values. You have the T and T naught already. Yeah, you have the T and T naught already, and then you have the R and R naught, and ask you to find what? Ask you to find alpha. If you use 50 minus 20, the 20 as the room temperature, the reference temperature, then you get correct alpha. If you use 20 minus 50, you get a wrong alpha. The value of alpha is different. Yeah, that means maybe I just write it down. Yeah, maybe I just write it down. The formula is R equal to R naught 1 plus alpha T minus T naught. Yeah. If you do it this way, this should be 6 and this should be 4. Yeah, this should be 4, and 1 plus alpha, and then 50 minus 20. 50 minus 20. This is correct. This is correct. You get a correct alpha because you maintain 20 degrees Celsius as the reference temperature. Yeah. But if you use the concept of final minus initial, yeah, the other way around you use the 20 minus 50, which you will get this one. You think that this one is a 4 and this one is 6, and 1 plus alpha 20 minus 50. You use the, like for example, you use the, like below, you use the final minus initial. Use the 50 as the initial. You will get a different answer. This alpha, you will get a different answer from this alpha. This one is wrong and this one is correct. Yeah, the top one should be correct. Okay, understand? You will get a different answer. You try and work it out, you get a different alpha. So remember, T naught is not the initial temperature, it's the reference temperature, and this reference temperature only take this value. Only take this value. Okay, let me show you more example from the past year questions. From the past year questions. Okay, look at these past year questions. So you see, like from UPS question 2012 and 13. I have this light bulb with this resistance, 190 ohm when lighted. See he say 190 ohm when lighted and 15 ohm when turned off. Find the temperature when lighted. He want the temperature. And give you the coefficient. Yeah. You see, alpha at 20 degrees Celsius. Do you see that? This alpha has this value at this reference temperature. You see, different temperature, different reference temperature will have different alpha. So why suddenly he tell you about 20 degrees Celsius here? Why he's trying to point you out? Yeah, this temperature, shouldn't it be somewhere in the questions? But why he put this temperature stick with alpha? As I said, alpha at 20 means that this is the T naught, this is the reference temperature, which I mentioned here. Alpha at reference temperature 20, this reference temperature is the T naught. You understand? It's the T naught. It's not the initial temperature, it's the reference temperature. So this 20 degrees Celsius is actually the room temperature, isn't it? It's the room temperature. It's the temperature when the bulb is turned off. So here it is. Yeah. It is the temperature. The one turned off actually is referring to the room temperature T naught, or the reference temperature, which is 20 degrees Celsius. Okay. So this 15 ohm, when the light is turned off, this 15 ohm should be the R naught. So we need to identify like this. Which one is T naught? Which one is R naught? And when it is lighted, it becomes hot, isn't it? When the bulb lighted, become hot. So this one is the temperature T, and this one is the resistance R. Okay, this is the resistance R, and this is the temperature T. So that's how we find out the value. You see, he asks you to find the temperature when lighted. That means I ask you to find this temperature. So how we going to do these questions? How we minus? So T minus T naught. How do we write? We use T minus 20 degrees Celsius. T minus 20. Our T naught must be 20. You cannot use 20 minus T. Understand? Now, let us look at the second question, which is a PSPM 2015 and 16. Now, this tungsten wire connect to this internal battery with internal resistance at room temperature of 23 degrees Celsius. You see, the keyword here is a special keyword, the room temperature. The room temperature of 23 degrees Celsius. As I said, what is room temperature again? Room temperature refer to the, you see, the room temperature. The room temperature refer to the reference temperature because 20 degrees Celsius is almost like room temperature. Okay, the room temperature is the reference temperature. But this time is the room temperature of 23, not 20, 23. So again, we also accept this as T naught. This must be the T naught. T naught. Room temperature 23 degrees Celsius is T naught. And then we have heated up to 190 degrees Celsius here. You see, 190. So this one should be the T. This one should be the T. So our T naught is 23 degrees Celsius. So when we minus, how we minus? T minus T naught, we should use 190 minus 23. You cannot use 23 minus 190. Understand? 23 degrees Celsius must be the room temperature. Okay. Then let us look at the next question. PSPM 2018-19. The resistance of wire changes from 8 ohm to 7.2 ohm when its temperature changes from 80 to 30 degrees Celsius. Calculate the temperature coefficient. He asks you to find the coefficient alpha. So how? So if you look at this one, this is a very good question. Which one is initial? Which one is final? Initial is the 80 degree. You see, this one 80 degrees Celsius is initial, isn't it? 80 degrees Celsius is initial, and 30 degrees is final. So how do you do? Is it you use okay, T minus T naught, then we use final minus initial. Yeah, final minus initial, which is 30 minus 80. 30 minus 80? Wrong. This is wrong. This is not 30 minus 80. It should be what? This T minus T naught is not about final minus initial. I emphasize again, it's not about final minus initial. It's about minus a reference temperature. So our reference temperature is actually the final temperature. Our reference temperature is the final temperature. This 30 degrees Celsius is the room temperature. It's the room temperature. 30 degrees Celsius is our reference temperature. So our 30 degrees Celsius is the T naught. Our final temperature is the T naught. So you use 30 minus 80? Wrong. Wrong. It should be, the correct one should be 80 minus 30. This one correct. Again, I want to say that our 30 degrees Celsius is the T naught, room temperature. Okay, our room temperature, 30 degrees Celsius is the T naught. Don't use the concept of final minus initial. Wrong. Okay? If you do the other way, 30 minus 80, you get a wrong answer. You get a different alpha compared to 80 minus 30. You usually get a different alpha. Try and work it out. Now, last question, the PSPM 2012 and 13. This year is a bit special. Yeah. In fact, actually, in the international book, Cardinal, yeah, also, actually, this past year question take out from the Cardinal, yeah, is same value. I saw same values and definitely from the question in the international books. Yeah, definitely question from international. Yeah, just alter a bit. But in fact, you see, this question a bit special. He say that this wire has resistivity L rho naught. Yeah, at T naught 320 degrees Celsius. This is definitely not the room temperature, isn't it? This T naught normally T naught is the room temperature, this acceptable value. But this time, he mentioned that the T naught is not at the room temperature, it's at 320 degrees Celsius. And now he asks you to find the resistance at this temperature of 420 degrees Celsius. So how? There's no room temperature 20 degrees Celsius or 0 degrees Celsius or 30 degrees Celsius for you to choose. It only give you these two temperature, 320 and 420. 320 and 420. So how do you do? Yeah. So how do you do? It is by since he already mentioned this is T naught. Do you see that? He already specially mentioned this is T naught. He already take this 320 degrees Celsius as the reference temperature. So we just take this as T naught because you already specify 320 degrees Celsius is the T naught. So we just take this as T naught. No brainer. Okay. So the answer should be T minus T naught. So because you already specify 320 as the T naught, so we just use 420 minus the T naught 320. Understand? I saw got one reference book. He write the other way around, which is T minus T naught, which is 420 minus he take a room temperature 20, and then he work it out, and then he choose another formula. He used 320 minus the 20 because he's not comfortable with using the 320 as T naught. So he do this way. He do two step. He do 420 minus 20, yeah, and 320 minus 20, and also get the answer. Okay, do you think this is correct? I already checked the international books. Actually, the international books, he just used this way. He never used two step. You can check the book, international book, Cutnell. Yeah, Cutnell. He just do one step. Not two step. Okay? Just do one step. Straight away. Because he already specified 320 is the reference temperature already. Yeah, it's the reference temperature. So just use one step. 420 minus 20. And that solves the problem. Okay? So, students, as long as you see this temperature 20 to 30 or 0, you take that as reference temperature. If the question already specified other temperature as T naught, just obediently use the temperature as T naught. Okay? And it always one step, never two step. Our answer scheme always only one step. Okay? So that's all for our videos for variation of resistance with temperature. Thank you. See you in the next video.